Good morning, everyone. Thanks for joining us on this webinar on for and while loops in the IEC editor. As usual, we'll go into it, and if you have any questions, you can put them in at any point, and we'll get to those at the end.
Hello and welcome to today's webinar. Today we're going to be looking at for and while loops in Cscape's IEC editor. Let's get started. Let's look at our agenda for today. We'll start by looking at what for and while statements are. We'll look at applications where loops can be useful, and we'll give you all the functionality details and examples for for loops, while loops, and repeat loops. There'll be demonstrations throughout, and we'll finish with a Q&A session. So what are for and while statements in structured text? These, along with the repeat statements, are essential in IEC programming within Cscape. They're used to create loops in your code, which are handy when you need to repeat a section of code either a fixed or variable number of times. Loops find utility in diverse applications. They play a crucial role in data analysis, enabling the execution of algorithms on datasets to find statistics like averages, minimums, or maximums. In barcode processing, loops prove invaluable for scanning specific characters, particularly terminating characters. Inventory management often involves using loops to search through lists, facilitating tasks such as loading process parameters or configuring machine setups based on identified matches. Also, loops are advantageous in printing tasks, especially when sequentially processing batches of archive data for receipt printing. Their versatility extends to various scenarios, making loops a valuable tool in programming and automation. Now we'll look at the for loop. It's essential to understand when to employ a for loop. Use a for loop when you need to repeat code a fixed number of times. The syntax is displayed on the screen, so we'll review it. After the for statement, you have the index, which is a double integer variable utilized as an index during multiple loop iterations. Remember to ensure that the variable is declared as double integer to prevent errors. Regarding incrementing the index variable by 1 in each iteration, you can omit the by step section of the syntax. When removed, the index will automatically increment by 1 with each loop cycle. However, if you desire a different increment value like 5, 10, or 2, you must include the by step portion in the syntax. In the statement area, we've shown it as one line, but you can have multiple lines and a series of statements executed in each loop iteration. This summarizes the syntax for the for loop. Now we'll look at the characteristics of for loops. They are straightforward to program and eliminate the risk of infinite loops, making them easy to use. If you have a fixed number of steps, for loops are a preferred choice due to their safety advantages. Some specific applications include initializing variables, setting array elements to 0, processing data arrays through algorithms, e.g. finding min or max values, and handling fixed length tasks like printing characters or processing barcodes. In all of these cases, the fixed nature of the task makes for loops an ideal choice. Now we'll have a demonstration on the for loop. Let's take a look at an example program here that we've written that is going to use a for next loop. In this main section of the logic, we're storing away in a shift register every scan the current value of an analog input. And this shift register is going to maintain the last 10 values of the analog input. So every scan puts a new value in the shift register, and so at any given time, the shift register has the last 10 analog input values. We want to find the average of these analog inputs so as to have a more stable signal. One of the advantages of IEC is that you can mix and match your languages. So we have this other main loop module here that has been written in structured text, and all it's doing is finding the average of all the samples that are contained within that shift register. Now for convenience purposes and the example, we put the syntax up here with all the details from the help file for the 4 next loops. So now we'll look at the logic here. So anytime we want to find the average of a group of numbers, we need to find the sum of all those numbers first. And then we need to divide that sum by the number of samples. So the purpose of our loop is to find the sum of all the members of the array that's contained in the shift register that has the last 10 values of the analog input. So this is a simple for next loop. First of all, we set the analog sum and we make sure our analog sum starts at 0. And then we also start our loop index from 0 to 9. So the loop index is going to be the index every time through the loop for the array that we're looking at. So we set that from 0 to 9 because that's the indexes of the arrays we're working with. We have 10 elements in the array. If we were doing an array of 100, it would be 0 to 99. And then every time through the loop, we're going to add current value in the array to our sum. And then we're going to move on to the next index. And when we're done, we have a sum of all 10 values in this case. And then our average is simply taking that sum and dividing by 10. So it's very straightforward. Let's look at that now on the bench. So here we have our I/O simulator, and as you can see, as we vary the analog value, the elements of the array of the last 10 scans are shown there at the bottom, and then the average is shown at the top. So this is a simple example of using a for next loop to find a sum of an array of values. Now we'll look at while loops. While loops repeat statements for an indefinite number of times. If you have a code section that needs to be looped and you're uncertain about the number of times, a while loop is your choice. Here's the syntax. The statements between do and end while run as long as the Boolean expression remains true. This Boolean condition is evaluated before executing the statements. If the condition is initially false, the statements may never run. Here are some key points about while loops. They can be tricky to program and may lead to infinite loops if not carefully handled. If the initial Boolean condition is false, the statements won't execute, which might not be the desired behavior. Infinite loops are a risk when your Boolean condition is perpetually true, especially when using real-world inputs in the condition. Real-world inputs are updated at the start of a scan, while loops run within the same scan, making it challenging to detect changes in real-world input states within the loop. When it comes to applications where you'd choose a while loop, it's ideal for tasks like searching through a list or handling variable length data, such as barcode processing or printing with varying content lengths. Now we'll look at the repeat loop, which resembles but differs from a while loop. Check the syntax on the screen. The statements between repeat and until run until the Boolean expression becomes true. Essentially, they repeat while the Boolean expression is false. This is different from the while loop. Additionally, you'll notice that the condition or Boolean expression appears after the statements. This can lead to the statements running at least once. As we compare repeat and while loops, we'll summarize the key differences. While loops run statements while the Boolean condition is true, whereas repeat loops execute statements while the Boolean condition is false. Importantly, repeat loops always run the statements at least once, as they appear before the condition. Conversely, while loops place the condition before the statements, meaning there's no assurance that the statements will run if the initial Boolean condition is false. Now we'll go to the bench and look at a demonstration of while loops. For the demonstration of the while loop, we'll start in our demo program on the bench as the best way to explain what we're doing here. So in this example, we have a list of 32 inventory items here at the bottom, and they're in an array from 0 to 31. We want to create some code that allows us to plug in a target value, and we want to be able to search this list and return the index. And then, if it doesn't find the value at all, it's going to return a value of 32, which is larger than the largest possible index, which is 31. So that's what we're going to do in our demonstration. Now we'll look at Cscape and see how we're going to accomplish that. So in the main ladder section, we're calling a subroutine every time the search inventory button is pressed on the screen. So that's what we're doing here. The find inventory subroutine is only going to be executed when the search button is pressed, and the code we're using here is utilizing a while loop. And the reason we chose a while loop is because we need to go through an array of values and we need to look for a specific value as a match. We may need to go through the entire array, or we may only need to go through a few values in the array. We don't know up front how many times we need to go through the loop until we find the value we're looking for. That's why a while loop makes sense in this scenario. So unlike the for loop, the while loop does not automatically increment your index if you're going through an array. So you're going to have to manually set your index that you're going to use in your array. As you go through and examine values in our scenario here, you're going to need to initialize that to 0. And the other thing you need to make sure happens is you need to keep in mind that with a while loop, the while loop executes the test before it goes through any of the statements. So you need to make sure, if you want to use a while loop, that you always execute the statements at least once. And you need to make sure that when you start your while loop, that your conditions that will cause you to fall out of the loop aren't true before you start. Now we'll look at the conditions that we're going to have in our loop. And there's effectively one condition but with two parts. So we'll look at that here. So the main thing here is that we're looking to see if our test value equals our target value. If it does not equal the target value, then we're going to continue to loop. If our test value, which is the value that we're examining as we move through the array one by one, if that value ever matches our target, then we're going to fall out of the loop. So that's the first thing that's going to cause us to fall out of our loop. The second thing is the second half of this AND statement here, which basically says if our loop index remains less than 32, we're going to stay in the loop. If our loop index ever gets to a value of 32 or higher, then we're going to fall out of the loop. We have that here because one of the problems with while loops is that if you're not careful, you can create an infinite loop if your condition is never met. So that's not what we want. First of all, we're going to see if the value and the target match. If they do, we fall out of the loop. And we're also making sure that if our loop index ever gets to 32, we fall out of the loop. So again, that's to prevent an infinite loop. Now we'll look inside the loop at the statements we're executing to see what we're going to do here. So the first statement, with the loop index starting at 0. Let's look at the first element in the inventory list, and we'll assign that to a variable called test value. Remember, Test value is one of the variables we're going to be checking as our condition. The next thing we're going to do is we're going to assume that the value matches, because if it does, we're going to fall out of the loop. And if it does before we fall out, we're going to want to set our inventory index, which is the result we're looking for, to whatever the current loop index is. And remember, if we aren't going to fall out of the list, then the fact that we made these equal isn't going to hurt because we're going to fix it on the next time around. And then finally, at the end, we have our loop index equals loop index plus 1 because we have to manually increment our loop index if we're going to work our way through this loop. So we're going to go through at a maximum of 32 times here with an index varying from 0 to 31. Now let's say we find what we're looking for. If we find what we're looking for, then the inventory index when we fall out of the loop is going to be set to the last loop index we use, which is the right answer. However, let's say we get through 32 times and we never found what we're looking for. So we have a bit of code here saying that if the loop index that we just finished up with here has a value of 32, that means the reason we fell out of the loop was because we never found what we were looking for. So now we'll set the inventory index result also to a value of 32, because that indicates we didn't find what we were looking for. So now we'll go back to the bench and verify that everything is working the way it should. Let's say we're looking for a value of 17. The value of 17 is found here, and that's an index of 20. So that's the correct answer. Now let's look for a value of, let's say, 9,999. And here we have a result of 32, because if you look carefully in this list, you'll see there is no 9,999. So this is working the way we want. So this is an example of using a while loop. Today we learned that for, while and repeat are statements that are used in the structured text language to create programming loops. A for loop is preferable in situations where code is to be repeated a fixed number of times, and you don't have much of a risk of any kind of infinite loop if you're using a for loop. While and repeat instructions are used when you need to repeat a section a variable number of times. And with those, you do have to take care to avoid infinite loops. But all loops and structured text are very powerful and a tool that any application programmer should become comfortable with. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, um, just one question about the issues. If we get into an infinite loop, it will cause the unit to fall over. Okay, I'm not seeing anything else. So next week we have a follow-on from our useful system registers webinar, which we had a couple of weeks ago. So we'll be going through a couple more system registers that can be used in everyday applications. Okay, other than that, there's not anything else in. Thank you all for joining us this morning, and we hope to see you again next week. Have a good day.